Alrighty, so I want us to have a look at properly doing sketching exponential graphs and actually going through and doing things like x-intercepts, y-intercepts, and also domains and ranges. Now that we've got a bit of a handle on different translations and transformations, let's make sure we're capable of going through and doing some of the maths. So the first thing I like to look for whenever I'm doing exponential graphs is any of those reflection stuff. Main reason is that's going to actually change the overall shape. If no reflections have been done, it is going to look like this. Somehow, some way, it's going to look like this. It might look like this if it's been reflected, and it might look like this if it's been reflected, or even like this if it's been reflected. However, you've got to first know what the original shape looks like. So let's have a play with this one. So if I was going to do a sketch and it asks for x and y intercepts, that's where to start. X int is when y is equal to 0. So we get 0 is equal to e to the 2x plus 1 minus 20. 20 to both sides, we get 20 equals e to the 2x plus 1. Take the natural log of both sides. The whole reason we take the natural log is to get rid of the e on the right-hand side. So we're left with the natural log of 20, which is equal to 2x plus 1. Subtract 1 from both sides. Divide both sides by 2, and we're left with x int is going to be there. So that is going to be the point ln 20 minus 1 over 2 comma 0. That is our x-intercept. Let's have a look at our y-intercept. Y-intercept happens when x equals 0. In this case, we're going to get y is equal to e to the 2 times 0 plus 1 minus 20. Well, that means we're going to get e to the 1 minus 20, which is just e minus 20. E to the 1 is just e. So our second point is going to be 0, comma e minus 20. Alrighty. From there, now we can go through and do the asymptote. So the asymptote, well, that's entirely to do with this constant on the end, this minus 20. Okay? And that's just because the only way to change the asymptote of a function is to vertically translate it. So it has only thing to do that. So for the asymptote is going to be y is equal to negative 20. Alrighty, so let's sketch it. Alrighty, so it's a traditional shape. Why? Because it hasn't been reflected. The moment we know that it's been reflected, then it's changing its shape. Otherwise, it's just stretching and pulling. In this case, it's been stretched and pulled a little bit. That's fine, but that's all. So negative 20 is going to be our asymptote. So it's going to start down here. And then it's going to hit in two different places. The first one is going to be ln of 20 minus 1 over 2, 0. The question is that a positive number or a negative number? And in fact, it's a positive number. A little bit hard to think of why, but you think of the natural log of e would be 1, and 20 is bigger than e. Why? Because e is about 2.7. 20 is bigger than that. So it's going to be a number bigger than 1 minus 1, which is positive over 2. So our our x-intercept is going to be some positive number over here. Let's look at our y-intercept. Well, our y-intercept is actually going to be 0 and then a negative number, e minus 20. And the reason that is e is about 2 and 20 is about 20. And 2 minus 20 is a negative number. So this is going to be down here somewhere. And so this is going to be the point 0, comma e minus 20. And this is going to be the point ln of 20 minus 1 over 2, 0. Alrighty, let's finish in our sketch. Oh my goodness. My lines only ever get worse in this, do they not? Alrighty, there we go. There's my beautiful sketch. Finish off with a few things. Alrighty, so that is my function. Y is equal to e to the 2x plus 1 minus 20. Alrighty, so the last thing we wanted to do was the range and domain. So the domain is going to be x is in R, or negative we could say, x is in negative infinity to infinity, or we could even say, as another way of saying it, is negative infinity greater than x. X is greater than negative infinity, which is less than infinity. Alrighty, so there's our domain. For the range is an interesting one. You can see that the range, so when we're looking vertically, that you can get any vertical position as long as it's above negative 20. Now we never actually hit negative 20, so it's going to be y is in the set negative 20 infinity, or you could do it as a domain, so y bigger than negative 20, and if you wanted you could even put less than infinity, but you wouldn't even need to put that in necessarily. Okay, just because this is enough to set up a lower bound. Alrighty, so that is the domain and range of that function. Let's have a look at the next one. Alrighty, so just as a big warning sign, you see there's a negative in front of that x. That means it has been reflected, so the shape is going to be different. We're going to worry about that in a moment, but it has been reflected. Let's do our x and y intercepts. So xint is when y equals 0. Let's do it. 0 equals e to the 2. Alrighty, I'll take the natural log of both sides, and we run into a problem. What is the problem? It's on the left-hand side, and it's that we're taking a logarithm of a negative number. No x int, done. Perfect. Y-intercept is when x equals 0. We get y is equal to e to the 2 minus 0 plus 1. Y is equal to e to the 2 plus 1, and there we go. So our y-intercept is going to be 0, comma, e squared plus 1, which is definitely a positive number. E is about 2, 2 squared is 4, 4 plus 1 is 5. So it's going to be between 5 and about 10, if you use 3 as the upper bound. Alrighty, so those are our x and our y-intercept. Now let's deal with the asymptote. Asymptote is going to be y is equal to 1. Why? Because that is the only vertical translation happening over here. Last thing is to deal with the reflection. So this reflection is affecting x. And when something affects x, that means that it's probably going to be to do with y some of the time. So the fact that it's hitting x means that it's going to be a y-axis reflection. So what does a y-axis reflection look like when we sketch it? Right, so let's just ignore everything else. When we reflect on the y-axis, it means we're going to get this shape where it starts at the axis and it points down like this. So it starts at the x-axis and points down. Alrighty, it's going to be some shift in that. You can see the fact that it has been moved means that it is going to be a slight shift, but that will be about it. Apologies. I've just done the y-axis reflection wrong. So obviously that was an x-axis reflection. This is going to be a y-axis reflection. So it's actually going to be on this shape. So it means it's going to slowly approach the x-axis coming down from on high. Now, hence no x-intercept, because if you draw this one, you are going to get some x-intercept, so you get some craziness going on. Alrighty, so the asymptote is at 1. So let's do that in first. So that's 1, y equals 1. And next we can have a look at that one and only intercept we've got, which is 0 e squared plus 1. And just a reminder, remember what the shape was. It was starting up high, and it was then approaching the asymptote from above. That was a terrible exponential shape. It's a little bit better. There we go. So there is my final function. Y is equal to e to the 2 minus x plus 1. Alrighty. So a few steps that are involved in doing that. let's finish off with the domain and range. Domain is going to be x is in the real numbers. You can write it in those other two ways as I showed on the previous question. I'm just lazy and I like saying x in RR. Let's have a look at the range. Now once again, the range is only defined from the asymptote above. So the smallest number for y is going to be 1, and the biggest number would be infinity because it has no upper bound, it's only got a lower bound. Or we could write that as saying 1 is less than y, and if you wanted, you could even say is less than infinity. Notice I'm using strict less thans, not less than or equal to. For it never actually reaches 1 and it never actually reaches infinity, but it approaches those things. Alrighty, so a little bit on sketching. I'll see you in the next one. Bye-bye.